Here in this video, we're going to look at the explanation for what delta is, and you're going to see this delta symbol a lot through your study of Calculus 1, 2, and 3. So here we're talking about just delta x, but we'll also look at delta y as well. So this is new notation for you. You've likely never seen it before. And one of the things that I want to note for you is that delta x is itself just one variable. So this delta x is a single variable. The delta and the x are not separate. It's not like it's delta times x. And delta x represents the change in the variable x. How does the variable change? Does it go from 1 to 3? Does it go from 2 to 7? What happens to it? Delta y, we could talk about that. Well, that's the change in the variable y. What happens to the y variable? Does our function go from an output of 2 to negative 6, or what happens? We can also talk about the change in t. In fact, we can talk about the change in any variable. So delta t talks about the change in the variable t. So we want to know how time changes. Okay. Now, it's pretty standard to when you talk about your change in your x, to go from the smaller subscript to the larger subscript. So I'm going to go from x1 to x2. It doesn't always have to be the case, and it'll be identified for you. Okay, so we're going to say delta x will be the change from x1 to x2. So like I said, usually go from the smaller subscript, not the smaller number. The smaller subscripts being x1 to x2, or a to b here. And so that's x2 minus x1. That's how we calculate it. We've been doing that. And so that'll be 10 minus 7, which is 3. So that means our change in our x variable from 7 to 10, it changed by 3. There's nothing necessarily amazing about that. Here's where it gets a little bit more confusing, and for the most part, we've only been talking about one dimension, but let's just take a look here at 2 dimensions. Let's say we got a function that looks something like this. And let's pick 2 points. And now we can, well, let's call this point A, we'll call this point B. Let's give it some coordinates here. So let's say this is a, I don't know, 1 over 3 up. And this is 3, I don't know, 7. I'm just making up numbers here. So what we can do is we can look at their images down on the x-axis, and we can say, okay, well, this guy is at 1, and this guy is at 3. And so we can, let's move this here, we can talk about the change in the x variable. And the x variable went from 1 to 3. So to calculate that, we just take 3 minus 1, and we get 2. And so the change in our x variable is 2 units. Then we can likewise, okay, so that's just that's this distance on the axis, right? Likewise, we can talk about the change in the y's. So this guy's down here at 3. This guy's up here at 7. And so this length right here, which we call delta y, that's going to be equal to 7 minus 3, which is 4. So that length is 4. So our delta x is 2 in this case, and our delta y is 3. Now they don't always have to be positive, right? So here's another function. Here's our point A. Let's pick another point B. Let's give A some coordinates. We'll say 212. And B some coordinates 5. Looks like maybe a height of, we'll just make something up here, 5, 6. Okay, we'll take their image down to the x-axis, and we'll look for this length here, because that is what delta x is. It's the change in the x. So the x variable goes from 2 to to 5. So the change in the x is 3. Okay. So now let's take a look at the y values. So we're going to go from 12 down to 6. And so that distance there, the change, is 6. Okay, but we should make that guy negative because the change is actually a negative 6.